Bismillahirrahmanirrahim. Assalamu alaikum. I hope every one of you will be alright. After finishing nitrogen, we come to phosphorus. Phosphorus being reactive, very reactive, it is not found in free state in nature or uncombined state. In nature, it occurs as phosphate rock, formula Ca3PO4 twice. Second, apatite, formula Ca3FPO4 thrice. And third is bone ash, which is the 80% source of phosphorus. Ca3PO4 taken twice. Allotropes of phosphorus. There are 6 allotropic forms of phosphorus. Only 3 will be discussed here. These 3 are white phosphorus, red phosphorus, and black phosphorus. First of all, few words about white phosphorus or yellow phosphorus. It is the very reactive allotropic form of phosphorus, highly poisonous, volatile in nature, waxy in origin, and yellowish-white substance. Second, it is soluble in benzene and carbon disulfide. Third, it exists in the form of tetraatomic molecule P4 as shown in the figure, which is arranged tetrahedrally. Fourth, it boils at 280 centigrade with vapors in the form of P4. If further heating is continued at 700 centigrade, these vapors become P2 form. Second allotropic form is red phosphorus. It is much less poisonous and less reactive. It is prepared by heating white phosphorus in the presence of catalyst, iodine, sulfur, mercury at 250 centigrade in vacuum. Third, the tetraatomic molecules of white phosphorus combine to form macromolecules. Polymers of phosphorus, a long chain as shown in the figure, is formed. The third allotropic form is black phosphorus. It is the most stable form under ordinary conditions. Black phosphorus is prepared by heating red phosphorus to high temperature and pressure. The structure of black phosphorus contains puckered sheets. Puckered means which can be folded. To give a better idea, it is the fluffy, silky cloth which is spread on the dining tables of a hotel. So that is the puckered arrangement of the cloth. So puckered sheets of phosphorus atoms with single bonds to each of 3 atoms. Owing to interconnected structures, black phosphorus has high melting point and boiling point and low reactivity. Now we start compounds of phosphorus. So first of all are the halides, which are the compounds of halogens with phosphorus. Phosphorus forms 2 types of chlorides: phosphorus trichloride PCl3 and phosphorus pentachloride PCl5. So first of all, phosphorus trichloride. Preparation. Phosphorus trichloride is prepared by passing chlorine over red phosphorus heated in a retort in a water bath. PCl3 distills over and is collected in a receiver cooled by water. 2 PCl plus 3 chlorine react to produce 2 PCl3. White phosphorus reacts spontaneously at room temperature. Properties. Colorless fuming liquid which boils at 76 centigrade and freezes at -112 centigrade. Second, PCl3 combines with chlorine to phosphorus pentachloride, PCl3 plus Cl2, giving us PCl5. Third, it can react with atmospheric oxygen to form phosphorus oxychloride. 2PCl3 plus O2, they form 2POCl3 named as phosphorus oxychloride. Fourth, PCl3 is readily decomposed by water with the formation of phosphorus acid and HCl. Equation of the reaction is PCl3 plus 3HOH giving us phosphorus acid H3PO3 plus 3HCl. Fifth property, PCl3 reacts with compounds containing hydroxyl groups such as alcohols and carboxylic acid. Hydroxyl group is replaced by chlorine. The equation is 3 molecules of ethyl alcohol plus PCl3 giving us 3C2H5Cl plus H3PO3 ethyl chloride. Then 3 acetic acid plus PCl3 giving us 3 molecules of CH3COCl named as acetyl chloride and phosphorus acid. Now second halide, it is named as phosphorus pentachloride. Preparation by passing dry chlorine through PCl3. PCl3 plus Cl2 gives us PCl5. Second method, PCl5 may also be prepared by passing dry chlorine through a cooled solution of phosphorus in carbon disulfide. 2P plus 5Cl2 giving us 2PCl5. Properties. It is a crystalline solid. 2. PCl5 is partially hydrolyzed with small quantity of water to form phosphorus oxychloride POCl3 plus HCl. Equation PCl5 plus HOH giving us POCl3 plus 2HCl. With excess of water, POCl3 is further hydrolyzed to form phosphoric acid and HCl. POCl3 plus 3 molecules of water, H3PO4 phosphoric acid plus HCl. The overall reaction by adding equation 1 and 2 is PCl5 plus 4 water, phosphoric acid plus 5 HCl. Third reaction, it reacts with metals to form their respective chlorides. Zinc plus PCl5 gives us zinc chloride plus PCl3. Fourth, PCl5 like PCl3 reacts with compounds containing hydroxyl group such as alcohols and carboxylic acid. OH group is replaced by Cl. Ethyl alcohol plus PCl5, we get C2H5 Cl plus phosphorus oxychloride POCl3 plus HCl. Similarly, acetic acid plus PCl5 gives us CH3COCl acetyl chloride plus POCl3 plus HCl. Oxides of phosphorus. There are two important oxides of phosphorus. First, P2O3 known as phosphorus trioxide and P2O5 phosphorus pentoxide. Now, first of all, phosphorus trioxide. Preparation. P2O3 is formed by burning phosphorus in a limited supply of oxygen. P4 plus 3O2 giving us 2P2O3. Properties. It is a white waxy solid with garlic odor. Second, its melting point is 22.8 centigrade and boiling point is 173 centigrade. It is poisonous in nature. Fourth, action of heat. When heated in air or oxygen, it burns to form phosphorus pentaoxide, P2O3 plus oxygen, P2O5. Fifth, reaction with water. It dissolves in cold water, forming phosphorus acid. It is therefore called phosphorus anhydride, P2O3 plus 3 water, giving us 2H3PO3. But it dissolves in hot water with explosive violence, forming phosphoric acid and phosphine. P2O3 plus 3 water gives us 2H3PO3. 4H3PO3 gives on heating is converted into H3PO4 phosphoric acid plus PH3 phosphine. Let us add these two equations. The overall reaction becomes 2P2O3 plus 6 water, giving us 2H3PO4 plus phosphine. Now the second oxide is called phosphorus pentaoxide, P2O5. Preparation. It is prepared by heating phosphorus in excess of dry air in oxygen. The equation is P4 plus 5O2 giving us 2P2O5. Properties. It is white powder having garlic odor. Second, it sublimes at 360 centigrade. Third, reaction with water. It dissolves in cold water with the evolution of heat, forming metaphosphoric acid, P2O5 plus water, giving us 2HPO3. With hot water, phosphoric acid, H3PO4 is formed, P2O5 plus 3 water, giving us 2H3PO4. Fourth property, as a dehydrating agent. Because of its great affinity for water, phosphorus pentaoxide acts as a strong dehydrating agent. Thus it removes water from nitric acid, sulfuric acid, acetic acid, and ethyl alcohol. Now the equations of the reaction are 2 nitric acid plus P2O5 giving us N2O5, nitrogen pentoxide plus metaphosphorus acid, 2HPO3. Sulfuric acid plus P2O5 giving us sulfur trioxide, 2HPO3. Then acetic acid plus P2O5, removal of water molecule, and reacting with P2O5 we get acetic anhydride plus 2HPO3. C2H5OH plus P2O5 we get ethene plus 2HPO3. Now oxyacids of phosphorus. There are two important oxyacids of phosphorus. Number one, phosphorus acid, and the other is orthophosphoric acid. Phosphorus acid preparation. Phosphorus acid is prepared by dissolving phosphorus trioxide in cold water, P2O3 plus 3 water, giving us 2H3PO3. Second method, it is obtained by the hydrolysis of phosphorus trichloride, PCl3 plus 3 water, giving us H3PO3 plus 3HCl. Properties. It is white crystalline solid which melts at 73.6 centigrade. Second, it decomposes into phosphine and orthophosphoric acid by heating. 4H3PO3 giving us 3H3PO4 plus phosphine. Reducing property. It readily combines with oxygen to form phosphoric acid and therefore strong reducing agent. It reduces copper sulfate and silver nitrate to copper and silver. Phosphorus acid plus copper sulfate plus water, H3PO4 plus H2SO4 plus copper. It reduces ammoniacal solution of silver nitrate to metallic silver. 2 silver nitrate plus H3PO3 plus water, giving us H3PO4 plus 2HNO3 plus 2 silver. Second step, 2 ammonium hydroxide plus nitric acid, ammonium nitrate plus water. Summing up these two reactions, we get silver nitrate plus H3PO4 plus 2NH4OH, giving us H3PO4 plus 2 ammonium nitrate plus water with a precipitate of silver. It reacts with oxygen. Fourth property, it reacts with oxygen to form phosphoric acid. 2H3PO3 plus O2, giving us 2H3PO4. Fifth property, nascent hydrogen produced by zinc and HCl reduces H3PO3 to phosphine. H3PO3 plus 6 atomic oxygen, nascent hydrogens, producing PI3 plus 3 water. Then is orthophosphoric acid, H3PO4. It is prepared by dissolving P2O5 in hot water. P2O5 plus hot water 3H2O, giving us 2H3PO4. Number 2. Pure phosphoric acid is prepared by oxidizing red phosphorus with concentrated nitric acid. 2 nitric acid giving us water plus 2NO2 plus oxygen. 2P plus 3 water plus 5 atomic oxygen obtained in the first step produced to give us 2H3PO4. Summing up these two steps, the overall reaction becomes 2P plus 10HNO3, giving us 2H3PO4 plus 10NO2 plus 2 water. The reaction can be simplified. Phosphorus 1 molecule plus 5 nitric acid, giving us H3PO4 plus 5NO2 plus water. Third, PCl5 on hydrolysis produces orthophosphoric acid. Equation of the reaction is PCl5 plus 4 water, giving us H3PO4 plus 5HCl. Manufacturing method. The orthophosphoric acid is manufactured by heating a mixture of powdered phosphorite or bone ash, calcium phosphate, and sand in electric furnace. So bone ash, Ca3PO4 taken twice, plus silicon dioxide 3 molecules, which is the formula of sand, reacts in electric furnace to give us 3 calcium silicate plus P2O5. P2O5 formed is absorbed in water to form phosphoric acid. P2O5 plus 3 water molecules, we get 2H3PO4. Properties. It is a colorless deliquescent solid having melting point 41 centigrade. It is soluble in water. Third, as weak tribasic acid, it reacts with sodium hydroxide to give 3 series of salts. NaOH, H3PO4, giving us sodium dihydrogen phosphate plus water. Then dihydrogen phosphate reacts with another molecule of NaOH to give us Na2HPO4 plus water. NaOH plus Na2HPO4 gives us Na3PO4 plus water. These three reactions are to be quoted if you are asked that prove that phosphoric acid is a tribasic acid. Then fourth, action of heat. On heating, it loses water and converted into pyro and metaphosphoric acid. 2H3PO4 giving us 240 at 240 centigrade removes one molecule of water, giving us H4P2O7 pyrophosphoric acid. Then on further heating to 316 centigrade, another molecule of water is removed, and final product is metaphosphoric acid with formula 2HPO3.